Why not working? Here it is working. There is no problem. Maybe check your internet. No, why you are uninstalling? I told now you should not uninstall. App is not a problem. Check your internet connection. That's it. Here we are getting. I checked just now in my app also. I'm getting. You just check your internet connection. If you are uninstalling, it won't allow you again without permission. So why you people are doing like this? Please check your internet whether Google is open or not. Please check and send a message. Don't make a call. Send a message, please. Okay, it's okay. Right. So good morning, all of you. Right. So the summary of the last lecture. I think yesterday we have not started this EM theory. Okay, for our students, they are going home yesterday. Okay. First, let me finish this EM theory class. If you have just 5 to 10 minutes time, then I will explain some more questions. Whatever I explained yesterday, topic is there. So I will explain some previous CSIR questions. Okay. So in the ending, first let us start this. So take a fresh page to the heading motional EMF. Motional EMF. Please take the heading motional EMF. Please check the audio and video. What is this motional EMF? Earlier we find the induced EMF. Now what is this motional EMF? This is also induced EMF. But the cause behind this is the motion of the conductor. That's why we call it as a motional EMF. Okay. So let us suppose here we have conductor. So this is nothing but the induced EMF only. Induced EMF. No change. But the cause behind this is simply the motion. Now here we have a rod, conducting rod. For example, let us suppose this one. Let us suppose this is the rod. Okay, a conductor of length L. This is a conductor of length L. Okay, this is a length L, which is moving with a velocity like this. So this is the rod of length L. It's moving like this. Good. Now here we have magnetic field, which is into the board. We have the magnetic field, which is into the board. So this is external magnetic field. So this is our situation. Here we have a conductor and which is moving like this, and the magnetic field is into the board. So it's like this. This is the magnetic field direction and the rod is moving like this. Okay, cool. Now see, whenever you have this conductor, okay, it's a neutral conductor. What is meant by neutral conductor? Positive and negative charges are in the same amount. Okay, so you will be having positive charges as well as negative charges, something like this. I hope you understand what I am saying here. Right. Good. Okay, fine. Now let us take a coordinate system first. Now I am defining a coordinate system. Let us say this is x-axis, and let us say this is a y-axis, and let us say this is a z-axis. I have taken this system x, y, z. Okay. So with this coordinate system, could you please define what are your quantities. First one, velocity. Of course, your velocity is nothing but v along which cap ma? X cap. And z is out of the board. See, z is out of the board. Z is out of the board. Then minus z cap is what? Into the board. Your magnetic field is into the board. That's why your V bar is equal to V, which cap ma? Minus Z cap. Because out you have taken Z. So then into is what? Minus Z cap. Next, length. Length is along which cap? Y. Okay. So L bar is equal to, we can take a L, Y cap, something like this. Good. So this is the situation. Now what I am saying is, for example, this is the conductor of length L, which is having both positive and negative charges, and which is moving with velocity v in the presence of magnetic field. Okay, then let me find the force. I hope everybody know what is the force here. For example, there is a charge electron. I am taking a negative charge. I am taking a negative charge. So let us suppose the charge is what ma? Minus e. Could you please tell me what is the force acting on the charged particle? Q V bar cross B bar. This is the magnetic force acting on a charged particle. Q into V bar cross B bar. Yes. Your Q is what? Minus E. And V bar. What is V bar now? Vx cap cross B bar. V minus Z cap. So minus minus plus E V, and this is what? B. X cap cross Z cap. X Y Z. So x cap cross Z is in a reverse direction. That's why what you will get ma? Minus Y cap. Oh. The magnetic force on the electron is given by EVB into minus Y cap. Okay. EVB minus Y cap. What is the meaning of this? This minus indicates what? I told you many times. A negative sign for a vector quantity always stands for the direction. And remember one more thing. Electric field will accelerate you and magnetic field will deflect you. That's it. Magnetic field will deflect you. It won't do any work. It won't accelerate. It will deflect the particle. So you have taken an electron here, negative charge. Now the negative charged particles are deflecting towards minus Y cap. Oh. Negative charges are deflecting downward or upward, because upward is Y cap and downward is what ma? Minus Y cap. So now you understand? Deflecting downwards. So once this process starts, that means the magnetic force, if you identify, then all the negative charged particles are accumulating here and all the positive charges are accumulating here. The negative charged particles are deflecting downwards, positive charged particles are moving upward. Okay, then what is the final situation? So if this is the rod and is moving with velocity v, then what will happen? During this motion, all negative charged particles are coming and deposited here, and all the positive charges particles are coming and deposited here. So now here we have positive and here we have negative charged particles. Good. Very nice. Now carefully see. Whenever charges are separated, potential difference is created. Electric field is induced. Why I am using the word induced? Earlier it was not there. Right now it is there. So that means what? Once the charges are separated, here we are having an electric field. Let us suppose this is E bar, and which is induced electric field. Good. Induced electric field. I hope you understand the process. For example, I am a conductor I'm moving with the velocity in the magnetic field, then all positive charges will come here, all negative charges will go there down. Then there exists an electric field which is from positive to negative. But electric field is nothing but a induced electric field. Good. Very nice. This is what Faraday is saying. Rate of change of magnetic field, induce electric field, something like that. Okay, fine. And right, I will ask a question. Now you got a doubt. What is that? Okay, sir is saying that if there is a rod with the positive and negative charged particles, and if the rod is moving, charges are separated. Now the doubt is how long they will participate in the separation process. After going here they will stop, after going at the end they will stop, after going somewhere they will stop. Where they will stop? That means definitely every system must come to the equilibrium. Equilibrium means what? See, in the nature, if any process is going on, if you got a doubt why this is happening like this, to attain equilibrium, that's it. So here also some process is going on. Positive charges particles are moving upward, negative charged particles are moving downward like this. Now the question is, how long they will participate? How long? Answer is till they attain equilibrium. Okay, my advice is better to keep it in I don't know which mode I'm doing. Wait a minute, I think I'm using normal width only, normal bandwidth. Shall I go for high bandwidth, or it is okay? You didn't get my point? Actually right now we are going for standard only. Is it okay, or you want to change it to high definition? Okay. If you want high definition, raise your hand.
High definition, that's needed.
Okay, fine. So I will keep it in the high definition. I request you please keep it in the medium mode. My advice is better to keep it in the medium mode, please. And one more thing, remember, your phone's displays are different to different companies. Samsung use one technology, another one is use another technology. So don't bother about those things. That will be the one of the reason why you are not having clarity. Something, so many reasons will be there. So I will go for this. Wait a minute, a small one. There is what? No, till the system attain equilibrium. That's good. What is the meaning of equilibrium? net force is equal to 0. Oh, net force on what? Charged particle. How many fields are there? Two fields. One is B, another is E. Oh, net force must be equal to 0. Okay, two fields are there. Could you please tell me what is the force due to this? Q into V bar cross B bar. This is the F magnetic. I hope you are listening. And what is the force due to electric? F electric is equal to QE bar. Good. And equilibrium means what? Both the forces are equal. Then QV bar cross B bar is equal to QE bar. Whenever two forces are acting, then simply take this equal and QQ gets cancelled and find electric field. Could you please tell me what is the electric field here? V bar cross B. Oh, the similar kind of relation you will get in atomic and molecular physics. The reason is the electron is moving in the presence of in the electric field of nucleus, because the nucleus is here and this is the positive charge and the electron is revolving like this. So if a charged particle is moving in the presence of electric field, you will get magnetic field. That magnetic field is this one. Some similar kind of relation will be there. Electric field, magnetic field and velocity. A charged particle is moving in an electric field, it will produce a magnetic field, something like that in atomic and molecular physics. Good. So now you got electric field E is equal to how much, Naina? V bar cross B bar. Come on, make it fast. You just adjust with the system. System never adjusts with you. You have to adjust. While you are writing or after writing, you just keep it in the low mode. Then you will save the data. While the class is going on, please keep it in the high mode or medium mode. And I request everybody, please off the WhatsApp messages. Please stop the notifications. Humble request, please. Make it fast. Anyone is facing issue, please.
Next very.
Actually, one more thing. From my side, bandwidth is also an issue. Actually, here it is uploading speed. We have to see uploading speed, and you should have good download speed because your device is getting, and I am uploading the video. So these are the factors actually. Okay, fine. Now if you are facing any issue from your end, please send a message. Otherwise, no need, just carry on. My request is put in the medium mode. That is my advice. If you have written, keep it in the low mode. I think some phones won't support high definition display. Not sure which phones you are using. Some displays are different. Right. Shall I pause this? So, a conductor is moving with velocity v in the presence of magnetic field. The charges are separating. So, this process continues till the system attain equilibrium. What is the meaning of equilibrium? Net force is zero or force is balanced. There are two forces. One is a magnetic, another is electric. So, definitely the forces must be equal. Then we got electric field E equal to V bar cross B bar. Are you ready? Listen. Wait a minute. Just go back to 9th class. The 9th class, they defined one quantity called work done. Work done. And some charged particle Q is having a potential V. That means this is a charged particle and this is applied potential. Then how much work is done on the charged particle? Q into V. Of course, everybody remember. So we know work done is equal to Q into V. V for potential. Here we are taking it as Q, E. E for EMF. It's not simply V, it is what? EMF. EMF is nothing but what? A potential only. So, EMF. Good. Of course, everybody know what is the work done. What is the work done, ma? F bar dot dl bar, which is equal to Q EMF. Okay. And you know which will do the work, electric field or magnetic field? Electric field. Then what is the force, Naina? QE bar. This QQ gets cancelled. Integral. What is the remaining? E bar. Don't forget. QQ gets cancelled. E bar is equal to EMF. You know, this is your Faraday's law, Maxwell's equation. Induced EMF is equal to integral E bar dot dl bar. If it is a closed loop, then you will get a closed one here. Don't forget. Okay. Now already we got E bar. Just take it and substitute. Integral E bar is what? V bar cross B bar dot dl bar is equal to EMF. Okay. Now once again go back to the situation. This is your length of the rod, which is along y-axis, means dl bar. This is your velocity along x-axis, E x cap, and this is your magnetic field V minus z cap, which is into the board. Now see, all these three are mutually perpendicular to each other. So whenever all are mutually perpendicular to each other, all are mutually perpendicular to each other. That means what? This cross product V and B is perpendicular to the plane. Which plane? V and B plane. For V and B plane, which is perpendicular? x. So that's why length is also along x-axis. Sorry, what you are taking? Sorry, x and v. So v bar cross b bar is nothing but perpendicular to the which plane? xz plane. For xz plane, what is perpendicular? Y. So this length and y cap both are same direction. That's why this completely, I hope you understand what I'm saying here. Integral VB, so 90 degrees, 0 degree. VB, what is this? DL is equal to EEMF. So V outside, integral DL is equal to E. So could you please tell me what is E? Why I have written, if I write E, you will assume it is a charge. EEMF. Now onwards, no need. E is equal to how much? B integral DL, L into velocity. Oh, that's it. Means if this is the conductor of length L, for example, this is the conductor length L, and here we have a magnetic field. Now the rod is moving like this with velocity V. Then how much EMF is developed here? VLV. V is the magnetic field, L is the length of the rod, and V is the velocity. Three factors it depends. B, L, V. Got it? Now the rod is moving translationally or rotationally? Translationally. So finally, conclusion, if you have a rod like this of length L which is moving with velocity V in the presence of magnetic field, then motional EMF E is equal to how much, Naina? VL. This is translational or rotational? Translational. Come on, write down. Still some people are coming late. That is not at all correct. Monday onwards, those who will come for late, next class your name will be on hold. That means you can't log in for the next class. Monday onwards. And the most important thing you have to remember this one. Motional EMF is equal to integral E bar dot DL bar. And if it is a closed loop, this one. So this is induced EMF, or motional EMF. One of the great of Faraday's law. This is very important. Don't forget. And this is the translational motional EMF. Translational motional EMF, BLV. So a rod of length L is moving with a velocity V in the presence of magnetic field B. Then what is the induced EMF? BLV. Shall I pop this? Yes. If you are not written, please raise your hand. That's it. Otherwise, I will proceed. So, a rod of length L is moving with the velocity V in the presence of magnetic field. What is the induced EMF? BLV, translational. And this also don't forget, Amma, induced EMF or motional EMF is equal to circular integral E bar dot dl bar. Again we'll come back to this. Stop. Okay, now we got already the first one, translational. Translational means we have this rod of length L is moving with a velocity V in the presence of magnetic field. Then EMF E is equal to, we got BLV. Now second one, rotational. Wait a minute. Now this time, this is the rod. This is the rod. Let us suppose. Earlier it is moving like this. Now it is rotating like this. So then what is the induced EMF developed? Okay, let us see. Now for example, this is the rod. This is the hinge, let us suppose. Okay, now it's a rotating. It's a rotating like this. Okay, good. With an angular speed omega, and the total length is L, and in the presence of magnetic field, this is the magnetic field, and this is the origin O, and the total length of the rod is nothing but simply L. Okay, now this time it is rotating. Now see, now it is rotating like this. For example, if I take a small elementary part here, everybody, small elementary part. I don't know whether you are able to see that white color. I hope you are seeing this yellow color. Now for example, I have taken a small elementary part. Everybody see carefully. Now if I am rotating like this, okay, see that yellow color only. Now this yellow color is moving in a circular motion. This circular motion like this. Yes. Whenever a particle is moving in a circular motion, it will be having a tangential speed. Yes. So what I am taking is, I have taken like this. This is O, a small elementary part of length dx at what distance, Naina? X distance. Actually it is a circulating. Then there will be tangential velocity V. V is equal to how much? V bar only, like this. I hope everybody know, whenever a particle is moving in a circular radius r with angular speed omega, then what is the tangential speed relation? V is equal to r omega. Now here the radius is nothing but x omega. I hope you got it. So V is equal to x omega. Good. Now what is the elementary length? Dx. Okay, good. Now there is a small elementary length dx is moving with velocity v in the presence of magnetic field B. Repeat. A small elementary length dx is moving with velocity v in the presence of magnetic field B. It's a translational motion because you have taken a tangential speed. Of course you understand what I am saying. Then Induced EMF is equal to B. What is the length? Dx. What is the velocity? X omega. Is it a total EMF or elementary EMF? Elementary EMF. E is equal to B omega. What is this? X dx. So integral. So B omega x square by 2. Your length is from where to where? 0 to L. From where to where? 0 to L. B L square omega by 2. So finally, the induced EMF or motional EMF due to rotational motion. Two motions are there. One is the translational, and this is rotational. So this is due to rotational motion. That's it. Come on. Make it fast and don't copy. Do it yourself. What I am saying is, for me, HD mode if I keep, I will upload with the high quality. Then, as per your requirement, you can change the clarity there. This is what I am saying. Okay, up to you. It's up to you. But I checked. Whenever I am keeping in the medium mode, okay. So normal bit rate and quality is also good. Maybe it depends upon the display, the phone display, this display. So that is a different for different phones. So pixel density will be there. Whenever you are purchasing any phone, first to go to that resolution. There will be pixel density, 440 pixels per centimeter cube, something will be there. I think Samsung will provide you around 500. Latest phones. This is 550. This phone is 550. Of course, it is not from here. But my advice, after a few days we will release the Windows app. So if you have laptops, then this high definition is very helpful. But you must have broadband. Remember, if you are having desktop or laptops, so please try to arrange broadband. Shortly we will release the Windows app. Okay. Right. Okay. Now, see this one. Ready? Anyone is writing? No. Now here is a bicycle wheel. Cycle wheel. Okay. Here is a cycle wheel. Listen. This was your maybe in BSc or MSc entrance. You have this question. I think you know some spikes will be there like this, some small thin rods will be there like this. Of course, these are conducting rods. Okay. Anyhow, let us suppose this is a bicycle wheel. It's some around 50 or 100 spikes or something like that. Spikes or spokes or something we'll call it as. And now it is rotating with an angular speed omega. And radius is r, of course. Radius is r. That means each rod length is what now? R. And it is rotating with an angular speed omega. Now he is asking what is the in the presence of magnetic field. In the presence of magnetic field. In the presence of magnetic field. If I ask the answer, of course you can't answer it. Because still, Babu, some people are coming late. So once again I am saying I hate latecomers. Simply I will remove your names without any reason. Teacher is coming at 4:30, 4:50, you will come at 6:30, 6 o'clock. This nonsense. If you are not interested, just leave it. Who told you to ask? Who asked you to attend the classes? Right. So now this is a cycle, bicycle wheel, which is rotating with an angular speed omega in the presence of magnetic field. Now what is induced EMF? I think if I ask, then also you can't write in the chat. I think maybe Monday onwards that voice will be activated, that we can ask. Yeah, see this one carefully. What is the answer? Now there is a rod of length r which is rotating with an angular speed omega. Like that, how many spokes are there? Let us suppose n number. Like this, n number are there. Then what is the answer? Is it same or n times bl square omega by 2? Is it same or n times bl square omega by 2? Just type the message. Is it same or n times? If anybody knows, just type. Is it same or n times?
Same.
Right, stop. 3 people answered same and 4 people answered n times. The answer is same. Answer is same. Why it is same? Listen. Everybody. For example, this is the very important. This is the rod of length L, which is moving with velocity v in the presence of magnetic field. Then what you are saying is there is an induced EMF. That induced EMF is equal to how much, Naina? BLV. This is what you have written. Good. For translational motion. If it is a rotational motion, B L square omega by 2. There are n rods, but still SAR is saying same. Why? See, every moving rod is replaced with EMF. Good. Which component is having EMF? Battery. So every moving rod can be replaced with a battery? Yes. Every moving rod in the presence of magnetic field can be equivalent to a battery of EMF, BLV. Is replaced with a battery of EMF, BL square omega by 2, if it is rotating. Good. Very nice. Now you got one more doubt. How this person is taking here plus, here minus? Yes. For this, I will tell a small technique. Take right hand. Everybody take right hand. Now fingers, current direction. Fingers, motion of the rod. Arm, magnetic field. Thumb, positive terminal. I repeat, again I am taking right hand. Earlier also I have taken, now also. Palm, magnetic field. Fingers, direction of motion. And thumb, positive terminal direction. That means, see this one, right hand, magnetic field into fingers, velocity. Your thumb is upward. Your thumb is upward means your positive terminal is up. I hope you have got it. Okay. So this is something like this. So this is the velocity direction and this is the magnetic field direction, and this is what? Positive terminal of the body, positive terminal of the battery. Don't forget, Naina, don't forget. So now come to this. How many are there? N are there. Each spike is replaced with VR square omega by 2. Yes. Each one is equivalent to is equivalent to EMF. How much EMF? B R square omega by 2. Now if you observe carefully, this is the battery and this is the battery and this is a battery, like this. All positive terminals are connected here, all negative terminals are connected there. That means what? There are batteries, N batteries of EMF E connected in parallel. Then what is the net EMF? E only. So net EMF is equal to how much, Naina? BL square, BR square omega by 2. Of course you understand now. Clear? Come on. Yeah, 3 students said same. Very good. Right. Come on. I think this is completed. Shall I put this part? Anyone is writing? No. Oh. So batteries of same EMF are connected in parallel, then the net EMF is the same. If they are connected in series, then it will be n times. Here it is a parallel, that's why same word, same, not n times. All right. Wait a minute. A small note, after that we will go to the problems. Okay, right. Small note. And Monday we are going to start what? Today is Friday or Saturday? Okay, whatever it may be. Monday we are going to start Maxwell's equations. Maybe within few days we will complete the EM theory also. Then we will go to the another paper. Right. Now here we have induced EMF is equal to circular integral E bar dot dl bar. Wait a minute. This is EMF or induced EMF. Good. One more thing, in the last class, day before yesterday class, we defined EMF or induced EMF, rate of change of magnetic flux. Of course, you remember E by dt of magnetic flux. Earlier we have done the problems by using this only. First you find phi, PA cos theta, then you differentiate it and you got E. And of course minus sign will be there. This minus indicates what? Opposition. This is opposition part. Always someone will be there who will oppose. Otherwise we won't work properly. Yeah? Right. So both the cases are induced EMF only. So that's why what shall I write, ma? Circular integral E bar dot dl bar is equal to minus d by dt of phi b. I hope you are observing. Minus d by dt magnetic flux, which is a circular integral. Of course, everybody know b bar dot ds bar. I defined already, you know. Phi is equal to d phi is equal to b bar dot ds bar, and the total is nothing but integral. Okay, and this is E bar dot dl bar. This is the line integral and this is a surface integral. Still, if you forget, E phi is equal to b bar dot ds bar. So this is the line and surface. First convert them into surface integral. That means this line integral is also converted into surface integral. You know, a bar dot dl bar can be written as del cross A dot ds. So del cross E dot ds equal to, ready? Wait a minute, minus, now carefully see this one, everybody. This is integral BDS, means this is the integration with respect to what? Space. Next, what you are doing? First you are doing integration, next you are doing differentiation. This is the differentiation with respect to time. Yes, two operations are there, A and B, two operators. These two are independent. Then A commutes with B. Then A comma B equal to 0. AB equal to BA. Means whenever two operations are commuting with each other, then they will commute with each other independent. Space and time are independent. If two operators are independent, first operation, second operation is nothing but second operation, first operation. That means order is not important. Only when both operators are independent of each other. This is the integration with respect to space. This is the differentiation with respect to time. Shall I interchange? Yes. Minus integral. Okay. So first differentiation, next integration. So differentiation, how much? Dou by dou t of b bar, b bar dot ds bar. Okay, now see what happened. First, what you are doing here? Differentiation. Next, what you are doing here? Integration. So I hope you got it. So here first integration, next differentiation. But here first differentiation, next integration. Good. Both are surface integrals. Then this is the integrand, and now this is the integrand. And could you please tell me how much it is? Rate of change of magnetic field. Rate of change of magnetic field. Induce electric field. Why it is induce? Curl is there. If it is an electrostatic field, curl must be 0. For an induced electric field, curl is 0. Curl is non-zero. So now you understand what I am saying here. So finally, it's a del cross E bar is not equal to 0. Means conservative or non-conservative? Non-conservative. So what is your conclusion? This electric field is a conservative or non-conservative? Non-conservative. Which field it is? Induced electric field. So once you go to the Maxwell's equations, remember two types of electric fields will be there. One is the electrostatic field, another is the induced electric field. Induced electric field is a non-conservative and electrostatic field is a conservative field. Hope you got it. Come on. Now we will do the problems. Very important. First note is clear. This is the motional EMF or induced EMF BLV, because it is in motion, BLV. Whenever you are dealing with the problems, then you have to take elementary one and after that integrate, you know. And the next one, magnetic force. Ready? Yeah? It's very important. Listen carefully. Second note. After that, we'll start the problems. Now here we have a rod of length L which is moving with the velocity V, and just now we have seen if it is moving with the velocity V, is induced EMF which is BLV, and just now you said it is replaced with the battery with the positive terminal upward, then definitely the current direction will be like this. If it is a loop, it is like this. Okay, I hope you understand what I am saying. This is a positive terminal, then it will start from here. If it is a loop, it will be like this. So now I got the current direction, and this is the magnetic field which is into, and this is the velocity. What about the magnetic force? Of course, you remember the magnetic force is equal to what? Current bill. This is the magnetic force. Magnitude is very simple to find. B as it is, I. So how to find I? Everybody know? This is simply E by R. Of course, it is having a resistance R. Then what is the current? E by R into L, so which is nothing but V E by R, L square V by R. This is nothing but magnetic force. Don't forget, Amma. Don't forget. Now coming to the direction. You know, right hand rule. So arm, magnetic field, fingers, velocity, current direction. Of course, you remember. So please don't get confusion. Right hand again, arm, magnetic field, fingers, current direction. Then the thumb will give you magnetic force. Forget, just to go back and see your notebook. I explained the right hand rule. Fleming left hand rule we have not used. Used this right hand. Fingers, current. Magnetic field, palm. Then what is the magnetic force, ma? This one. Don't confuse it with this battery EMF. For battery EMF, I again used the right hand, but fingers velocity and palm magnetic field, thumb positive terminal. But here fingers current, palm magnetic field, thumb force. Got it, ma? Come on. Let us finish the problems. I think this is E BLV by R. I think one more B square. B square. B, one more B is there. Come on, make it fast. Shall I pop this left part? This half. Shall I pop this?
ಯಾಕೋ ಅರ್ಜೆಂಟಾ
Now here we have two parallel rails and there is a conductor rod of length L is moving with velocity V, and this is the resistance and this is the magnetic field, original magnetic field. Now we have to see what is the current direction and everything. Ready? Yeah? So all of you please listen. Now how to get the current direction first? Ready? Yeah? First we have to find the EMF, induced EMF. How to find? There is a rod of length L which is moving with the velocity V in the presence of magnetic field. Then the motional EMF is nothing but what, Babu? BLV. Then could you please tell me what is the current, ma? E by R. How much? BLV by R. Good. Now come to the current direction. Don't get tension. Apply our technique. Now, for example, the rod is moving like this. Then the area of this region is keep on increasing. If area increases, flux increases, then originally is strong. Original or B original is strong. If B original is strong, B induced is opposite direction, same direction, opposite direction. What is meant by opposite direction here? Out. So B induced is out. B induced is out means current is clock or anti-clock? Anti-clock. But we are interested in this rod. Okay, right, wait a minute. So good. Now we got the current direction also. Next, immediately what you find? Magnetic force. Magnetic force is equal to what? Bill. B as it is. I is what? BLV by R into V. So how much? V square, into L. V square, L square, V by R. This is the magnetic force. Of course, everybody understand this one. Any trouble, ma? Come on, make it fast. Sometimes they will ask power delivered. Everybody know what is the relation between power and a force? Power is nothing but a force dot velocity, F dot V. F is already there, V is already there. Power is equal to V square L square V square by R. And now if you want to find the magnetic force direction, 1 minute Amma, everybody see, I hope you know this. And if you want to find the magnetic force direction, everyone is getting one doubt. What is that? Which magnetic field I have to use? Original or induced? Repeat, original or induced? Original. For magnetic force, always we have to go with original. So then use the right hand, palm magnetic field, fingers current, thumb magnetic force. Ready? Your original magnetic field into current upward. So this will be the magnetic force direction. Good. Come on. After a time interval, after some time interval, after a time interval. This is very important question. Now this is the rod of length L, which is moving with velocity V in the presence of magnetic field B. And here is a resistance. What is asking? It's very important. Find the velocity after a time interval T. Oh, is asking velocity. To get it, remember, this is the classical mechanics. What you are studying is a classical electrodynamics. In classical mechanics, whenever they are asking velocity, go for Newton's second law. No more second thoughts. If they are asking velocity, immediately go for Newton's second law. That is the only one equation which will give you velocity. Classical, as per classical concept, right? Okay, he is asking velocity. Wait a minute. Whenever they are asking velocity, go for Newton's second law. Newton's second law. Could you please tell me? F is equal to ma. Yeah, we will write F equal to ma. It's not simply F. If it is F net, it is what? F net. Total net force is equal to ma. Everybody know? Acceleration is what? dv by dt. Oh, if I find the net force on this rod, then that is equal to m dv by dt. Then I can find the velocity after some time t. I hope you understand. For that, what I need? Ma force. How many forces are having? Remember, whenever in a horizontal motion, if the body is moving horizontally, no gravitational force. If the body is moving vertically, then there will be a gravitation. Don't forget this. For all horizontal motions, we will neglect the gravitation. For all vertical motions, we have to consider the gravitational motion. Good. Sorry, gravitational force. So there is only one force. What is that? Magnetic force. How to find? First, induced EMF. How much? VLV. VLV implies current I, E by R. VLV by R. Once you got the current, what is the magnetic force? Will. Current will. How much it is? V square, L square, V by R. That is your force. Now immediately you have to find the direction of the force. Told you, right hand, fingers, current, thumb force, palm magnetic field. Which magnetic field? Original magnetic field. So we have already seen current is like this, already seen that, and palm into the board, fingers current direction, thumb force. There is only one force, that's why I hope you understand now. MA is nothing but m dV by dt. Do you please tell me what is that single force? V square L square V by R is equal to m dV by dt. I hope you know how to solve first order differential equation. Bring this m this side. Okay, a variable separable. What is that? Variable separable. I think most of you know. Those who know, you can do it, Amma. No need to wait for me. Come on, do it. V square L square V by R is equal to m dV by dt. Remember one thing, if you want to learn physics, first you need mathematics. Without mathematics, it's not possible to understand. Make it variable separable, ma. Bring this V this side and remaining this side. So that's why dV by V equal to V square L square by mr into dt. Variable separable. Bring this V this side and dt this side. So integrate. Come on, do it. Initial velocity v of 0, final velocity v of t, and this one 0 t. Come on, do it. One by x integral log x. You know, I hope everybody know how to solve that. Log v and v of 0, v of t equal to b square L square by mrt. So finally this is I hope you got log of v of t by v of 0. So you understand what I have written here. Log a minus log b equal to log a by b is equal to b square L square t by mr, and finally v of t is equal to some mistake happened. What? Anybody identify? Velocity direction, magnetic force direction, both are opposite. Both are opposite means here what you have to take here? Minus sign. That you forgot. Here, not here, here. Please take minus sign here because both are opposite. Check there. Just put a minus sign. V of 0 I think you know what is this? E raised to minus b square L square T by mr. Because this value is equal to e raised to this, and v of t is equal to v of 0 e raised to. If anybody don't know, so I'm seeing most of you people are wasting the time by sleeping. After the class sleep, and in the night, whole night wake up, and no use at all. Remember, you are not wasting the time, you are wasting one lifetime. Again, you won't get this life. You are wasting the lifetime, not 1 hour, not 2 hours. This age is not preferred for sleeping purpose. If you are simply sleeping without doing any work, no use at all. This is the time to work hard. This is the time to build your life. This is the time to build your career. Otherwise, the whole life you have to depend on some other else. No one is studying, no one is reading. Everybody is sleeping. Because waking up at 5 o'clock. Yeah, I am also waking up at 5 o'clock. But I'm seeing all these hostler students. I don't know why they are doing like this. No one is studying properly. Remember one thing. Other people, you are having advantage over other people. So classes are going on and you are in touch with the subject. Still, if you are not doing work from your side, it's very difficult. Yeah, third problem. Right down. Now here I have last model amount. Listen. Now this is the current carrying wire. See, I told you, although we said 100 times, you won't do actually. You have to get it. I have to study. This is my life. This is my career. You have to think like that. Now there is a rod, okay, and this is a long wire, infinite wire. One end is at a distance A, and this end is at a distance 4A. Okay, now cool. This is the current carrying wire. Now what is happening? This rod is moving with a velocity v. Okay, this is a conducting rod, is moving with a velocity v, and one end is at a distance A, another is at a distance 4A. Now carefully observe. Who is giving the magnetic field? This wire is giving the magnetic field. Shall I ask a question? The magnetic field, whatever this rod feels, is it same from this end to this end? I repeat, this is the rod and this is the current carrying wire. This wire is giving you magnetic field. Of course, everybody know what is its magnetic field. Infinite wire, mu naught I by 2 pi r. R is the distance. Now tell me, from here to here, do you have same magnetic field? No. It's a non-uniform magnetic field because here X different, here R different, here R different, here R different, here R different. R value is different. That's why how to do this? So what we have to do is, for this I have to take an elementary part. This elementary length is what ma? Dx is at a distance. What distance ma? X. Then could you please tell me, at this point the magnetic field is equal to mu naught I by, what is the distance ma? 2 pi x. I hope you got it. Now as per the problem, there is an element of length dx is moving in the magnetic field with velocity v. I hope you understand what I am saying here. Now with this scenario, what is the elementary EMF? Just now I told you elementary EMF is equal to B dl V. So elementary EMF is equal to V. Here we have taken dx into V. What is the magnetic field? Mu naught I by 2 pi x dx into V. So mu naught outside, 2 pi outside, I outside, V outside, integral. I hope you understand. What is 1 by x? Log x. Now your x is varying from this end to this end. This end is at a distance a. That end is at a distance 4a. Come on, do it. Over. Make it fast. I request you close all the background applications, stop the internet connectivity to all the applications except this. There is a provision actually, if you see the settings, we can stop the internet access. Most important thing, Truecaller. My advice, better to uninstall Truecaller, which is the dangerous app and which will take maximum power and maximum internet connection, because more background process it is having. It will look up, it will see your messages, it will see your calls log, everything. Please uninstall that Truecaller. One of the dangerous app you are using, that is Truecaller only. But we will keep. Why? We are interested to know who is calling. Okay, very good. Who will call? Whatever the people who knows you, they will make a call. Next, try this one yourself. Griffith question. I think this is A. This is B. Similar one. Just for practice, do it. I think AA gets cancelled and you got log 4. Log 4 is equal to 2 log 2. Again 2 gets cancelled, log 2. This is very important model. Induction is completed. Tomorrow you are having exam at 9 o'clock. The syllabus is, Biot-Savart law also there, and this induced EMF, EMI, electromagnetic induction. So exam at 9 a.m. to 11 a.m. Syllabus EM theory, Biot-Savart law, and EMI. Whatever we have done till now, after Biot-Savart law, it is EMI. Ampere's law, that not that much important. And electronics, only op amps. And the people who are listening this, other people who are attending the EM theory by paying the fees, on Thursday we are going to start solid state physics, and the duration is around 25 classes, 25, 1.5 hours or something like that, 25 classes. So those who want to attend, I request you, please pay the fee as early as possible. See, 25 classes means per class how much you are paying? Not even 100 also, 100 rupees also not. So don't think it's a huge money. Monday we will close the application, we'll close the process for SSP. On or before Monday, I request you, if you want to attend, so you just pay the fee by Monday. On or before Monday, please pay the fee amount. ನಿಂದೇನು ಬರ್ತಿದ್ದು
ಅದೇ ಎಲಿಮೆಂಟ್ ಇದೆಯಲ್ಲ
and one more thing, we are going to start the online classes for December CSIR batch also. If you are having friends, classmates, if anyone are interested, if you like these classes, prefer, otherwise leave it. Because as per my knowledge, in India the corona effect will be till, I think, we don't know, it will be there. Maybe we will reach the peak point in June and July month. That's why I told you earlier, possibility is there, please make arrangements and go home. Okay, but I think Maharashtra students went, I think. You have to see the arrangements for other states also.
ಇವನೇ ನೋಡ್ತಿದ್ದಂಗೆ ಮಾಡ್ತಿದ್ದಂಗೆ ಎಲ್ಲ.
Okay, fine, no problem. Let us see. Problems will come on. So tomorrow you are having exam, so don't forget, please go and practice, please write the exam. Exam is not meant for your knowledge. It is only a measurement to know how much you learned. That's it. Okay, I learned 50%, I have to improve. Let us improve. Try to get 60% next time. That's it. That is the only exam main point. Measuring knowledge and all these things now. Okay, so I hope you have done this, and sign out, log out. Please press the stop button and press the home button, and after that recent applications, close it first, then come to the login for electronics. Thank you, and yeah, come for electronics.